Hi, hello guys. Welcome to the new session of linear integrated circuits. In this session, we are going to learn about the contents of introduction to operational amplifier. Let us see the diagram as shown in the figure is called operational amplifier. Now, we have one doubt such that why this diagram is called op amp. It means operational amplifier. What is the difference between other electronic instruments and this instrument we are going to discuss. The definition says that op amp is a high gain directly coupled multi-stage amplifier and it has differential input and single-ended output. It means that if you see here we have one input plus it is connected to positive terminal and one is connected to negative terminal. It means that it is a differential input. It means that we can give input either plus terminal or minus terminal. It may be it consisting of two saturation voltage, one is plus Vsat and other one is minus Vsat. Both inputs we are processed through this instrument and we get a single output. But anyway, in some of the instrument also we have two inputs. Why it is the difference between that instruments and this instrument? Now we are going to learn. Operational amplifier is nothing but it can allows both AC signal and DC signal, and along with that it can perform addition, subtraction, multiplication, integration, logarithmic operation and also performs anti-logarithmic operation. That's why this instrument is called operational amplifier. Now let's move on to further. Here plus terminal, if you give input to the positive terminal then it is called non-inverting input. If you give input to the inverting terminal then we call it as non-inverting input. Now let's see what are the terminals. We have basic. We have majorly classified 5 basic terminals. One is if you give input to the positive terminal then it is called non-inverting input. If you give input to the negative terminal then it is called inverting input. And if you process these two inputs through the op amp then we get one output that is called V out, that is a single output terminal, and we have two saturation levels in this. It is nothing but we are giving some input voltage initially to the op amp to perform some basic operations. So that is Vsat and minus Vsat. Now let's see how the pin diagram of an op amp, a basic op amp of IC742 is looking like this. Here we are, as we are discussed in the earlier, here we have positive terminal and a negative terminal plus Vsat minus Vsat and output. That's and all we are going to discuss here. Here if you see here the terminal 2 is called inverting input and terminal 3 is called non-inverting input, and plus V7 and 4 is called plus Vsat and minus Vsat. Sixth pin is called output, and this offset null, and it is the 8th terminal is not connected, and 1 and 5th terminal are initially the op amp has if you give whatever the voltage, that total voltage will not be appear on the output side. There must be a fraction of error should be there, that must be to nullify this one. We are going to use this offset voltages. In the upcoming session we are going to discuss in detail regarding the what is meant by offset null and offset null. Now let's see ideal operational amplifier. What is meant by ideal op amp? If you see the operational amplifier diagram of ideal op amp, which is having non-inverting terminal and inverting terminal, if you the difference between both two are Vd and the output voltage is V0. If the two input terminals, one input terminal, the plus and minus symbol input refers to the inverting and non-inverting. If you give the input as 0 degrees on the output side, it shows negative off. If you give input to the positive terminal, then it will show as it is whatever the input you are giving, that will be refers as the output. If you give output to the input to the non inverting terminal, then output will be the 180 degrees phase shift of the input. If you observe here, I am taking the input as a sine wave which is of maximum amplitude peak to peak voltage is 2 volts. Then after processing through the inverting terminal, then output will be the 180 degree phase shift of the input. If you observe this if you process the input through inverting terminal, then output would be the 180 degrees phase of the input terminal.